Yes, those who have marked their attendance, uh, now, okay, now we can start our session. And those who have not marked their attendance, then they can do it later. And hopefully, my screen and my screen is visible to you, and my voice is audible to you. Just please confirm me yes on our chat box, and then I will start the today's lecture. Okay, thanks. Thanks. Let us start with the yesterday we have done a general overview of digital image processing, and today's in a today's lecture we are going to start with the first chapter, which is a introduction to digital image processing. And for this chapter, I have followed the digital image processing book by Gonzalez and Woods. You can refer any edition, but the recommended is the latest version. But if you are following the second edition, then there is no any big problem. And please note that these PPTs are uh, modified version of a basic deep PPT. And let us start with the uh, brief history and the basics of the digital image processing. First, we have to cover the digital image, and yesterday we have already covered this point. One second, I have to take the marker. Okay, yes, digital image processing is a two-dimensional function. It is very clear. There is x and y. X and y are representing the spatial coordinates, and the f is the amplitude, which is representing the intensity of a gray level within that image at a particular point. So, and the next one, there is another important parameter in a digital image that is referred to as a pixel. And as we know that the pixel is the smallest element of a digital image. And we can also say that digital images are composed of finite number of elements, and each of which has a particular location and the value. And another important point, how we can link the digital image processing with the artificial intelligence. As we know that there are fields such as computer vision, whose ultimate goal is to use the computers to emulate human vision, including learning and being able to make the interference and uh, and take action based on the visual inputs. And this area itself is a branch of artificial intelligence whose objective is to emulate human intelligence. And it is, as we know that in artificial intelligence, there is a first requirement. You have to analyze the inputs and how you can analyze. There are multiple sensors are there, but the most important sensor is the imaging sensor, which acquires the image, and that particular image is, or we can extract the feature from that particular image with the help of digital image processing. Then a machine can take the actions according to the requirements. So this is all about the artificial intelligence, but the base of actual artificial intelligence is the digital image processing. Uh, However, and let us start with the some uh, brief history about the digital image processing. And as we know that one of the earliest applications of a digital image was in the newspaper industry, and there is one of the major requirement. And when the pictures were sent by submarine cable between the London and the New York, this is the first platform or a first transmission has been occurred between the London and the New York. And what they are using the telegraph printer. And telegraph printer is nothing but it is a device, and here you can just see the visual of that particular printer, telegraph printer, and where the some alphabets are there and the some numeric value is there. And this one of the that is you can say that there is a keypad where you can write the some keypads. But yes, if you want to design a picture, then there is a made up of this a small dots within the within that particular in an image. And there is another example of a digital picture in which the tape punched is used. Now, what is a tape punch? That is again that is again the dots has been created on a tape. There is a particular tape is there. There is a specific size, and in which dots are created, and to design a particular image. So here you can see that in a figure 1.2, this image is actually created with the help of the dots, and which is referred to as a tape punched machine. So the next one important point is that the earlier Bartlein systems were capable of coding the images up to the 5 levels of gray. And yesterday we have already covered this point. There are basically there are huge range of gray levels, but yes, the human eye can interpret up to the 16 levels of the gray. And in the earlier Bartlein systems are capable to distinguish between the 5 different levels of the gray, but this capability has been increased up to the 15 levels in 1929. And how they have done this one? They have done with the help of there is a system for developing a film plate via light beams. So, which is modulated by a coded picture tape improved the reproduction process considerably. So, you just have to remember that in a 1929, they have improved the grayscale level up to the 15, and with the help of a film plate via light beams. So, there is a example. Okay, yeah, there is one more important point. They have used the 15 tone equipment. 15 tone equipment is that is representing the 15 different gray levels of the uh, 15 different levels of the gray color. So this image has been created with the help of our different 15 different color levels, gray color levels. And the next is the first computers. As we know that the previous are they are just we can say that that is a analog form, and which is not actually digitally processed by the computers, because in 1920 there are no supercomputers out there. So in 1960, when the powerful computers come, and then they can process the images by means of a digital, and work on using the computer techniques for improving the images from the space probe began at the Propulsion Jet Propulsion Lab, which is also referred to as a JPL at California in 1964. And it is the first time when the picture of the moon transmitted by the Ranger 7, that is launched by the again NASA, and were processed by a computer to correct the various type of various distortions available in the atmosphere, and there is some different illumination effects are there. And in order to correct that kind of a noise, which is exist on a Ranger 7 image, and we have used the computer. So you have to remember this point. There is in an initial state, there is a first in which we have used 5 levels of the gray. Then there is a 15 levels of the gray is present. And then the computer there is a first time the images have been processed for the space images. That is there is a moon image which is required from the NASA. There is by Ranger 7. And to why we have used that particular image for the digitization, to remove the noise or to enhance the some desirable properties of the or desirable features of or within that particular image. So in parallel with the space application, the digital image processing has also been used in medical imaging. That is a remote Earth resources observations and the astronomy. So with that, the invention, yes, that is one of the most important. The invention in the earlier 1970s of the computerized Excel tomography, that is also known as a, CT scan nowadays. That is a computerized tomography, and it is one of the most important events in the applications of the image processing in the medical diagnosis. And these are the contributors, and these two are the contributors of the in designing and developing of the uh, 3D scan machine. Uh, just hold for a second. Bye. Bye. Okay. Yes. Hopefully, my voice is clear to you. Just okay. Yes. Hopefully, my voice is clear to you. Just please confirm me so that I can proceed further. Yes. Dhananjay, are you there? Yes. Dhananjay, I okay. Okay. Thanks, Aarti, for confirming me.
Yes, sir.
Yes. Yeah, we are talking about the space applications, and after that, it is used in a medical imaging as well as for the remote Earth resources observation and astronomy. And there is a yeah, please hold for a second. Yes. there is a one major application of in a medical imaging, that is a CT scan. That is one of the most important application in the for the medical diagnosis. And it is also interesting to note that the X-ray were discovered in 1895, as we all are aware of that, what the X-ray can do. They are actually, we are using the X-ray machine for the detecting the cracks in between the okay, there are multiple applications. That is, the first one is in a medical applications. We are using to identify the crack within the bones, and the another applications we are also using the X-ray for the to identifying the uh, there is a breakage between the there is a conducting lines within the PCB circuits that we will cover in upcoming slides. And X-ray were actually discovered in 1895 by the William, uh, for which he received the he received the Nobel Prize for Physics in 1901. So after 16 years, he got the Nobel Prize for that. And these two inventions, CT scan and the X-ray, they have nearly 100 years apart led to the some of the most important applications of the image processing today. So these two are the actually main applications which have been used for the medical diagnosis. And yes, next one is that is electromagnetic spectrum. And today there is almost, as we know that there is no any technical area where the digital image processing is not being used, and it is everywhere. And as we are talking about the artificial intelligence, it is available in the automobiles. It has been used in remote sensing images. It is used in civil engineering, and there are a lot of applications that we will discuss in the upcoming slides. Now, these images were based on the radiation from the electromagnetic spectrum. As we all are familiar with that particular term, electromagnetic spectrum, and they are actually expanding. There is a huge range of electromagnetic spectrum, but the digital image processing has found its application in the different regions. That is the first one is gamma rays, X-rays, ultraviolet, visible, infrared, microwaves, and the radio waves. So these are the major areas and the area of applications of our digital image processing, and for the different applications and the different fields. And let us start with the gamma rays. Now, the major use of imaging based on gamma rays includes the nuclear medicine and the space observations, that is the astronomical observation, and how these images have been generated with the help of the gamma ray detector. So, in order, here you can see that there is a first two figures that is shown in figure, that is one second, that is shown in figure A and figure B. These are actually medical image, and as we also know that there is a PET scan image, and the another one is there is a space image. These two are the space image which is acquired from the NASA, and which has been used for the astronomical observations. So these two are the major applications of the gamma rays or gamma imaging. And then there is a next application of a digital image processing in X-ray. And the X-ray is one of the oldest source of electromagnetic radiations used for the imaging. As I am discussing earlier, that is the best used for the medical diagnosis, but they are also extensively used in the industry and the other areas. Other areas including that is astronomy and how where we are using in industry to identifying the break in between the conducting wires as shown in this figure. That is a image of a PCB or that is a kind of a motherboard is there, and you can or we are using the X-ray machines to identify the breakage between the uh, between the conducting lines. So the X-rays for medical and the industry imaging are generated using the X-ray tube. And what is that particular X-ray tube? That is nothing but a vacuum tube in which there is a cathode and anode. Two terminals are there, and these are some samples. And where we are using that is a chest X-ray. There is a angiogram. There is a head CT scan, and then there is a circuit board that is very obvious, and this one is the last one for the astronomical application. Now, uh, now the another one, there is a third application of digital image processing that is based on the ultraviolet light, which is used for the extensively used for the fluorescence microscopy. So what is that fluorescence microscopy? It is one of the growing area of a microscopy, and yeah, these are the resultant images, and in which the fluorescing areas are shining against the dark background with a sufficient contrast to permit detection. And please note that the darker the background of non-fluorescing material, the more efficient the instrument. So there is a point where you can guess the what is the potential of that particular instrument to which is used for the microscopy. And these are the applications or output images where the actually ultraviolet light is using. And yeah, these are also some applications. There is a anti-cancer, that is a figure A. Please note that these are the actually terms which are defining the figure number. There is A, B, C, this D, E, F. That is according to this one. So you can just go through these terms. That is a anti-cancer agent image. That is a cholesterol image. There is a microprocessor image, and there is a nickel. Yeah, this one is the most important. That is a nickel oxide thin film, and we are used in many applications for material studies. And there is a E. This is a E figure. That is actually a surface of a audio CD. Uh, we earlier in a earlier past decade, we are using the audio CD or compact disc, and this is actually uh, image of that particular uh, disk or surface of that particular disk. And this one is a organic superconductor. So this is a image of a yeah. There is a another broad application nowadays. The digital image processing is very popular for Earth observation, and so that's why we can say that the application of a digital image processing in remote sensing. And there is a infrared band where we are just talking about the infrared, but please note that in a remote sensing images there are a lot of bands are existing, and in infrared band it is definitely it is used with the visual imaging. It is used in conjunction with the visible bands or imaging as in a remote sensing applications. So in a remote sensing applications, the satellite images actually consist of the multiple bands uh, that is acquired on a there is on a red band, green band, blue band is there, Then there is a infrared is there, short infrared is there, shortwave infrared is there, and there is a far infrared is there, thermal band is there. So there are a lot of bands are there, and here we are talking about only the infrared. But yes, here you can just check it out. There is a Landsat image. Landsat is a satellite which is launched by the NASA, and yeah, there are yeah. Let us talk about these bands. So as there are different bands are there, but here we are more interested in these four bands. That is a near infrared, middle infrared. Please note that this one is a near. There is a near, middle infrared, and this one is a far. This is a far, middle infrared. And what kind of information we can get from this near infrared and the thermal infrared and this middle infrared? And please know that these are the applications and these are the wavelengths where this image is required. And the thermal infrared is actually used for the soil moisture and thermal mapping or for the detection of the fire forest. Oh, sorry, forest fire. And infrared is used for to identifying the biomass and shoreline mapping, moisture contents available within the snow and vegetation. So these are some applications where we can use the uh, digital image processing in the field of remote sensing. And yes, it is also used in for the detection or the prediction of the natural hazards. And this image is required by NOAA satellite that is acquired on 2005. And these are the infrared satellite images of the America. There is America continental is there, and these are the some uh, infrared images, and these are the images of Asia. There is Asia. Yeah, this one is India. That is near infrared images, and these are the some other examples of digital image processing um, where we are using, and we are using in industries to identify in to detection of the break in between the conductors and to identify the medicine. And there are some microscopic applications are there, some study of a material and identification of the levels of a liquid in between the bottles that is used in the industry. And you can just go through this. Uh, yeah, that is air bubbles in a clear plastic product. So, there is no any single, but there are a lot of applications of infrared. There is not only infrared, there are a lot of uh, bands are there, and you can use it to find the application. And yes, at a toll plaza, we are using the image processing to detect the numbers of a car and make it little bit automatic process. And yes, there's a fingerprint is there, and to yeah, paper currency to identify the there is original or a fake currency. We can use the image processing. Yes, there is a one most important application of digital image processing. That is in a microwave band. So in yeah, in the previous images, that is generally the images were acquired during the daytime when the light is when the sunlight is there, and the sensors which are available on the satellites, they acquire the images during the daylight. But and the second point is that they are generally affected by during the presence of the cloud. If the cloud is present, then there is very low possibility they can acquire the exact image of that particular area. So on that particular uh, or in order to solve that particular problem, we are using the microwave band images. So some radar waves can penetrate the clouds, and under the certain conditions, they can also see through the vegetation, ice, and dry sand. So these are the certain there is a you can say that there is a potential of a microwave which can detect the vegetation, ice, dry sand, and snow. So this can also do with the microwave imaging. And yes, if the okay, I will cover this little bit later. And in many cases, the radar is only a way to explore the inaccessible areas of the Earth's surface. And yes, and yeah, there is a in a radar image, one can see only the microwave energy that was reflected back towards the radar antenna. So here you can just check it out the image of the mountain and which provide us the information regarding the altitude of that particular location. And we can please note that the microwave band image we can use during the day, during the night, and during the clouds because it can easily penetrate through the clouds. So there are a lot of applications of the microwave band, but the only limitation is that it doesn't provide the that is high spatial resolution. That is a what is it? There is a little bit you may be confused about that. What is the spatial resolution? The spatial resolution is representing the that is okay. I have to cover that point also. So, for example, there is an image. So, this one is a pixel. That is a pixel, which is a smallest element of an image. And now the point is that how much area is covered by that particular pixel. Uh, for example, let us take notice. So, in the case of the optical sensor, that is based on the that is RGB, red, green, and blue. And here I will take the example of a Landsat, that is whatever we have covered earlier. That is a Landsat. They are offering the information at a 30 meter of resolution. So what is that meaning 30 meter of resolution? So the single pixel of an image is actually representing the 30-meter area of that 30-meter area of that particular region. So, for example, there is a one pixel is there like this. There is a one pixel. That particular pixel is there, and it is representing the 30-meter area of that particular region. So, in the case of the microwave band, the spatial resolution is a very low. So it is around there is normally 100 meters to not 100 meters. That is roughly that is in kilometers. So they are offering the information at a kilometer range. So the one pixel of that particular pixel is representing the 1 kilometer by 1 kilometer. That is 1 km of width and 1 km of height. Sorry, length, not height. There is a 1 kilometer. So it is giving the information at a kilometer range. But the optical data sets, which is available in the form of the red, green, and blue, and which is actually acquired on a sunlight, they are providing the information at a very high resolution. So as you know that when you are watching the Google Earth images, they are very clear to you. So they have a very high resolution around 2 to 2.5 centimeter and or in point 2 to 0.8 meters. That is a range of Google Earth. So they are offering a very high resolution, but the micro data they are giving the very low resolution images. So yes, we are also using the digital images in a radio band, which are used for the magnetic resonance imaging. And hopefully you all are aware of that. What is MRI images and why we are using that? And these are the some examples. There is a knee. There is an image MRI image of a knee, and this one is a MRI image of a spine. So that we can use for the medical diagnosis. And these are the some yeah these are the different reasons uh, where we can use the digital image processing. That is a collaborative images. That is in a gamma application, in X-ray, and in optical, in infrared, and in radio. So these all are used for the astronomical observations or space application. And this is a yeah, this is a cross-section image of a seismic model, and where the arrow is actually representing the hydrocarbon or a oil or gas trap. So these are the applications of ultrasound and ultrasound imaging, which is used for the identification of the health of a baby, uh, and to identify the some other features. And yeah, this one is a image of tungsten filament, and the B figure is representing the damage integrated circuit. So these two are very high resolution images, and yeah, there are some other applications and where we can use the uh, where we can use the okay, just hold for a second. Yes, yes, yes. Please note that yesterday we have uh, done a different steps involved in a digital image processing. And please note that yesterday we have done the fundamental steps which were required from the digital image processing book from second edition. And in fourth edition, there have been some updation have been done, and we can just go through it so that we can understand what are the those steps which has been introduced in fourth edition of digital image processing. And the first is you have to identify the problems, and the image acquisition is basically involves the acquisition of the image and convert into the digitized form. And the next step, that is second step involved in digital image processing, that is the image filtering and the enhancement. And it is generally used for to enhance images or to in the form of contrast, stretching, in the form of increase the brightness or to remove some undesirable noise. So the another important point, that is a third step involved in digital image processing, that is image restoration. As we know that we have some that is we have acquired the image. Uh, okay, that is the best way to explain with the help of examples, and you can just please go through my yesterday presentation, and you will get or you can easily recognize what is the image restoration, and it is, and in the form of definition, it basically restores the image which has been destroyed by some undesirable noises. So this is a short definition of image restoration, but to recognize the difference visual or recognize the visual difference between the there is a input image of a restoration and the restored image, then you can just please go through my previous presentation or yesterday presentation. And the next, there is an additional step involved in image processing, that is referred to as a color image processing. But in some applications, this part is not generally used. So you can skip this part if you doesn't require. But yes, for the color applications, you have to use this. For example, in X-ray, there is no any requirement of a color image processing, so you can ignore this step. But for the remote sensing applications, there is a huge applications of there is a very significant role of a color image processing to identify the different features of the Earth surface. And the next one is there is an emerging area of a digital image processing that is referred to as a wavelength transformations, and it is basically a representation of an image in different resolutions. So that I will cover in detail in upcoming lectures. And the next one is a compression and the watermarking. Yes, compression is to just compress the image, and there are some formats are already there. There is a JPEG is there, Joint Photography Expert Group is there, and then BMP format is there. There are a lot of formats for to compress the image. So there is there is another parameter involved in compression. There is generally watermarking, which is generally used for the security purposes. And but hopefully you all are aware of that. What is the watermarking, and what is the role of that watermarking within an image, and morphological processing. Why we are using the morphological processing? They have a lot of applications, and here we are actually using the logical operation, uh, kind of AND operation, OR operation. There is a XNOR operation, that whatever we have covered yesterday. And segmentation, segmentation involves there is a separation of the of different objects within that particular image. And once you have extracted those objects, then you have to extract the features. That is a subsequent step of a segmentation. Once you have separate the object in an image. For example, you have extract the tree uh, from an image, and the next task is to detect the shape of that particular tree. So that is done by the feature extraction, and to labeling that particular shape is referred to as a image pattern classification. So there is a subsequent step of a feature extraction. This one, image pattern classification. So hopefully you all are aware of that. These all steps, and these all are the basic basic chapters involved in digital image processing. And there is a one more important point. There is a components of a general purpose image processing system. And how we can do it image processing? Yes, we need a computer, and we need a image display, and we need a master OS to store that particular image, and there is a cloud is there, so that we can store, or we can just uh, we can share our information through a cloud. And how we can acquire the image? We need a image sensor, and that particular image sensor is depends on your applications, and it can be a gamma detector, it can be your X-ray detectors, and it can be your there is a RGB, there is a sensor, infrared sensor, and whatever. That is again that particular sensor is dependent upon your applications. And once this sensor acquired that particular image, and it is processed through a hardware. Yes, you need a hardware to process that particular image, and you also need some software to process that particular digital image. And there is a hard copy. Yes, if you need a, printed form, then you can take it through a printer. Uh, so these are the essential components of the uh, image processing system. So in order to that, uh, in order to yeah, yeah, please, in order to implement or process any image digitally, then you need a this type of a system which includes all these steps. And those okay. If there is any query, then please you can ask me on a chat box, or you can ask me directly. Hello, you can ask me directly, and okay, please, if you have any question regarding the introduction to our digital image processing, then you can please ask me. And if you don't have any problem, then you can please mark your attendance for today. And the links are already available to you. And please note that there is a CU, there is a two links are there. One for to mark the attendance, and one link, another link for view the attendance. So you can mark your attendance and view accordingly. And please note that there is a CUHP for the HP campus students, and there is a CUPB for the Punjab campus students. And the 4044 is your that is a course code of our digital image processing. So you can mark your attendance and check your attendance accordingly. And, yes, please, if you have any question, then please, you can please ask me. Uh, or you can just mark your attendance and confirm me once you have marked your attendance, and then you can leave the session. And okay, Dhananjay, yes, please. Dhananjay, you have joined this session little bit later. So make sure that you have also marked your attendance uh, for yesterday also. Please confirm me. Dhananjay, if you have marked your attendance for yesterday and for today as well, then you can leave the session, or you can please confirm me first. Okay, all the students, make sure that you have marked your attendance for the yesterday as well as for today. So marked for, okay, Himansh, there is no any problem. You can, okay, fine, Dhananjay, if you have marked your attendance for the yesterday also. Now, if you have any question, then you can please ask me, or if you don't have any question, then you can leave the session. And this PPT will be provided to you via Classroom, and the same video lecture will also be uploaded on your Classroom.